Okay guys, welcome back. So in the last video I explained to you about two examples in which logarithmic functions are used. In this video I'll be explaining to you as to how logarithmic equations can be used with two examples. So I'll take two examples like this. First of all, I'll take something like this. Now if you were given, let's say, ln 20 plus 3 ln x, right? Ln 20 plus 3 ln x is equal to ln 4 plus 5 ln 2, something like that, right? Something like that. So how can you find the value of x? Now first of all you need to understand, since now this is some term, this is some term, this is a logarithmic term, this one, this is another term, this is a logarithmic part, and so this logarithm plus this logarithm is a whole, the left side of this equation is a logarithm, and this is a logarithm, and this is a logarithm, so this part is a logarithm and this part is a logarithm, so the addition will be also a logarithm. So the right hand side is also a logarithm as well as the left hand side is also a logarithm, so this is called a logarithmic equation. So I explained to you in one of my previous videos about the concepts of logarithmic equations. So here I have to find the value of x using those concepts I explained to you. Alright. So you know that if you were to find x, you have to isolate x or you have to solve it using both sides. So there are two ways, either to isolate x and then find the value, or solve for the right, solve for the left and solve for the right, and then equate x and isolate x and find it. So what I find easy, I explained to you in my previous video, what I find easy is isolating x, because you have to only write the value of x as 1, so you will save time as well as you will get rid of many errors when you are solving it. So what I'll do here is that I'll isolate x and I'll take this term to the right and solve for the right. I'll isolate x in the left side, so I have to solve for the right, and then I'll say x is equal to some value depending on the value I get for the right. Alright. So first of all, what I'll do here is that I'll say this is equal to 3 on x, right, plus equals, I'll take this term here, so that it will be ln 4, right? I'll take this to be ln 40, right? Ln 40. I'll take it to be ln 40, otherwise it will be minus, plus 5 ln 2 minus ln 20, right? Ln 20. Alright. So what actually happens is that now I have isolated x in the left side. Now I have solved for the right. So first of all, before solving, I need to know whether this in the form of ln a plus ln b or ln a minus ln b. Now this term is some logarithm. The coefficient is 1, as well as now here is a minus, and this term is a logarithm and the coefficient is 1. But this term, although it's a logarithm, its coefficient is 5, right? The coefficient of value here is 5, right? So first of all, what I have to do is that now I have to make it into the format of ln a plus ln b or ln a minus ln b. So in order to do that, I have to make the coefficient 1. So as I mentioned in one of my previous videos, what I have to do here is that if you were to apply the equation, you have to eliminate this 5 by making it a power of here, the value of here 2. So first of all, I have to do that as the first step, as the second step of this solution. So this is also equal to ln 40 plus, now this 5 goes here, ln 2 to the power 5, 2 to the power 5, this 5 now goes here, right? This 5 goes here, minus ln 20 is the same. Now I'll solve for this one, so it's easy into, if you were to do the equation. So this is ln 40 plus ln 32 minus ln 20, right? Minus ln 20. So now you know that this is in the format of ln A plus ln B minus some ln C, right? Ln A plus ln B minus ln C. So first of all, I'll take these two terms, right, and take the solution of those two terms, and then I will take the solution of the whole. So if you were given in the format of ln A plus ln B, from the concepts of logarithms, you know that this is equal to the value of ln inside 40 times 32. 40 times 32, if it is in the format of ln A plus ln B, we have to multiply those because there's a plus sign here, and this minus ln 20 remains here. So now here is a logarithm, this part is a logarithm, right? Now the whole value is a logarithm here. And here's a logarithm, so this is in the format of ln A minus ln B, ln A minus ln B. So if you have in the format of ln A plus ln B, you know that you have to multiply here. And also if you have in the format of ln A minus ln B, what you have to do is you have to divide this. So this is also equal to ln 40 times 32 divided by 20, right? The whole value of this divided by this. So if you divide like this 20 and this 2 will cancel, so this will be equal to ln 64, and so this is equal, the right hand side will solve for ln 64. Now in the left hand side, as I did here, right, I had to take the power of 5 as the base of 2, right, to the numerical value of 2. So what I here do is that this is also equal to, I will say this is also equal to x to the power 3, right, x to the power 3. So here it goes here. So this is equal to x to the power 3. So ln x to the power 3 is equal to ln 64. So what you can take is, if you take anti-log, you can say x to the power 3 is equal to 64. So x is equal to 64 to the power 1/3, that is equal to 4. Because 64 is plus, you have to take only the positive one, right? So the value of x is 4. So if you replace x here, ln 20 plus 3 ln 4 will be equal to ln 40 plus 5 ln 2. So that's just a simple example in which logarithmic equations come into play. So I'll take another value, take another equation, so that will be easy for your further understanding of logarithmic equations. So let's say I'll take something of a proof, right? Something of a proof. Now we have been given that if you are given a squared plus b squared is equal to 7ab show that, so the question is asking, show that 2 ln a plus b divided by 3 2 ln a plus b divided by 3 is equal to ln a plus ln b. Ln a plus ln b. Now you know that there is, now you know about how to solve for x when you are given some trigonometric equations, but this is somewhat of a different approach in which you have to find, now this is not just a solution, this is a proof, right? So you can also make logarithmic equations in order to prove, in order to remind the concepts of logarithms. So in this equation you have to prove that this term, the left hand side, is equal to the right hand side. Now we have been given the value of a squared plus b squared is equal to 7ab. Now how to solve for this? Now you know, now you have a plus b here, so what you can say is that now you have a squared here, b squared here, but you can form a plus b unless you know the value of this one. So what I'll do is that there are two ways to solve this, either to take the left hand side or to take the right hand side, right? So it's easy for me if I take the right hand side and then solve for the left hand side. So what I'll do is that I'll take the left hand side of this equation, the left hand side, and I'll solve to prove that the left hand side is equal to right hand side. Then finally I'll say this equation is true. So this left hand side is equal to 2 ln a plus b divided by 3. So as I mentioned a little while ago, if you have some coefficient here, what you can do is that this is also equal to this term as a whole, to the power of this one. So this is also equal to ln a plus b divided by 3 whole thing squared. So this is equal to so this is actually 1/9 of a plus b squared, right? A plus b squared. So this is equal to 9 ln 9. This is a squared plus b squared plus 2ab, right? From the expansion of a plus b squared. So this is equal to ln 1/9. So a squared plus b squared has been given as 7ab. So I can directly substitute that here. So that is equal to 7ab plus this 2ab comes here. So that will be ln. So 7ab plus 2ab is 9ab. So that 9ab divided by multiplied by 1/9 is equal to ab. Now you know that if you have a multiplication inside a logarithmic term, you can write it as an addition of the individual logarithms. So this is also equal to ln a plus ln b, right? This is also equal to ln a plus ln b. So that is actually the right hand side. So that is the right hand side. So you can say that down here, right? So the left hand side is equal to the right hand side. So this equation or this this equation is true. So that's just another example, some example that is going away from the basic concept. Now you know how to solve equations. Now you may have been solving equations from the examples you have been taken from various sources, but this is just this is another example in which you have to prove it using logarithms, right? There may be also proofs. So this is just an example to show that how to prove logarithmic equations. Now you know how to prove trigonometric equations or trigonometric identities and so on. So this example shows that how to prove a logarithmic equation. So in this video I talked to you about logarithmic equations. So in the next video I'll be talking about a new concept under math, and see you then.